Hey guys, welcome to take 2 of this edition of Answers with Abdi. I had to restart the recording because my cat would not stop meowing. So we are back. I'm going to work out problems 1 and 2 on your homework for this section. So pages 27 and 28 is what we're looking at. So when you have a growth or decay rate that is in a percentage, so for example, number 1, we're looking at 3.2%, you are going to use this equation right here. So you have some givens, right? And looking at your equation, you already know that A stands for initial, R stands for rate, and T stands for time. And so in your givens, you have an initial amount of money, that's $2,500. You have a certain amount of rate, which is 3.2% or 0.032 if you divide it by 100 to get it to a decimal. And then there's a couple of variables that are given, right? Y is going to be your balance and X is your time. It's your number of years. So before we even plug in what the information that's given in A, you know that your equation is going to be Y equals your initial amount times 1 plus your interest rate to the power of time. Now in A, we are also given a certain amount of time. So that's supposed to be an arrow, forgive me. You've got $2,500 times 1.032 to the power of 12. To figure out how much money is going to be in your account, you are going to plug this equation straight into the calculator. So let's go ahead and try that. When you plug it into the calculator, it should look something like this. Your initial value, 2,500 times 1.032 to the power of 12. When you put that in, you get $3,648. And I know you can't see the decimals on your screen, but I promise if you plug it in, you should get $3,648.35. So that's how much money you have after 12 years. What was it? I believe it was 36.48. Let me double check my work. 36.48 and 35 cents. You want to make sure you have the proper amount of decimals, right? We're talking about cents, so we're going to go down to the hundreds, and the proper amount of units. Now for B, we're asking you how much it's going to take for the account balance to reach $100,000. So now what you have is a Y. You have an amount balance. Your initial stays the same, and your growth rate stays the same. The only thing you don't know in this question is time. So you have to use what you know about exponential and logarithmic functions to solve for that exponent place. So first you want to isolate this term. You want to get this term all by itself, right? Remember, for some of you, I explained the soldier metaphor. You want to get your enemy as isolated as possible. So the first thing you are going to do is divide both sides by 2,500. When you do so, it cancels out on the right. On the left, you are left with 40 equals 1.032 to the power of X. Now think about your most recent class and how we brought those variables back down to earth. You have to use a log with a matching base to cancel it out. So on the right and on the left actually, so let me erase that parentheses, I'm going to use log base 1.032. On the right hand side, that cancels out. On the other side, I get that X equals log base 1.032 of 40. Now when I plug this into my calculator, hopefully this will work, we should get math alpha math, log base 1.032 of 40. And that gives you 117.11. Now for that means that it's going to take you 117.1 years. In total, when the proper amount of decimal places for years is just to the ones place. So it's going to take you 118 years to reach six figures, right? To reach $100,000 at that interest rate. So now let's try another problem, number 2. So here you're given a quantity of insulin. It regulates sugar in the bloodstream, and it breaks down by 5% each minute. An adjusted dose, an original dose, is going to be 10 units. So here we're talking about a decimal rate of 0.05. If we're breaking down, we're going to subtract. This is a decay factor. And your adjusted dose is your initial value, that's your A, which is going to be 10. 2A is giving you a time period 2. So how much insulin will be left in the bloodstream after 40 minutes? So because the because the rate of change is happening in percentage, you have to calculate that percentage decrease using that same equation we had before. That's why I zoomed out so you can see that equation. Now you have y equals your initial rate, A, times 1 minus 0.05, because we're decreasing, it's breaking down, to the power of 40, right? Because this rate happens 5% each minute, we want to see how long it takes after, how much you'll have left after 40 minutes. So essentially what you're doing is 10 times 0.95 to the power of 40. So by now you should be able to do this on your calculator on your own, so I'm not going to show you the work for that. But for this, in your calculator, you should get 1.2, oops, I said read 1, but I said 2, 1.29. I got 1.285, so I'm going to round it to my hundredths place. If you're not given a specific thing to round to, round it to your hundredths, and you see that your unit is just units. So after 40 minutes, this is how much insulin is left in your bloodstream. Now, B is asking you how long it will take. That's your clue that you're looking for time. You're given a quarter left, so you want to figure out a quarter of 10, but your initial rate is still 10. Your decay rate is 0.95, and you're doing it to the power of time. Now a quarter of 10, right, you want to divide 10 by 4, which will give you 2.5. So you want your end rate, or excuse me, your end value to be 2.5. So what do you do to get x all by itself? First, you divide both sides by 10. When you do so, on the left, you get 0.25. On the right, you get 0.95 to the power of x. Now you want to get that x all by itself, so you're going to do log base of 0.95 on both sides. On the right, you get it canceled out. On the other side, you have log base 0.95 of 1/4, or 0.25. I know that's hard to see. And if you do your sweet little math alpha math, you should get 27.03. Make sure that you not only have your place value correct, but also your units. We are talking about 27.03 minutes. That's how long it takes for you to have a quarter of insulin left in the bloodstream. I hope this video helps. Please reach out with more questions. Don't be afraid to take risks on these problems. I'll see you in the next class.